Hello and welcome to my first video for the Advent of Code. For those of you who don't know, Advent of Code is a set of challenges that gets released in December, and it goes from December 1st to December 25th with a new challenge getting released every day. I've already completed day 1, so in this video I'll be talking more about how to approach day 2 and then using TDD approach to solve it. I'll also be publishing the code later on my GitHub repository, and I'll share the link in the description. So if you like, you can read the story, but that's not something I care about to solve the challenge. What I've also done is I've already set up my test data to be in a JSON file, and this just uses a utility that I wrote, which allows me to use XUnit theory data and read all the input from a JSON file. If we go back, you can see there's a puzzle input which is pretty large. It's a pretty big data set, and this changes from person to person. It's a different data set. So I've already copied over the example data that they gave along with the result. The second subset is the puzzle input that I had, and I've put in the result as 0 because that is something I don't know, and once I write the code for this, the result should become apparent, which then I can plug into the site to get part 2 of the problem. So part 2, the data sets remain the same. It's the same input that you get. So let's start with this. So you can see the problem is called dive, so that's what I'm going to give class dive tests. We can start with the theory test. It's going to be, and I can just copy that from my previous one. JSON data file. This is a day2 test data, and this will take a list of string, and that's just what is the input that it's giving and what's the output. And we can copy that as well for the time being because it's going to remain the same. And then we can go back to the problem statement, and what we're trying to do is what do you get if you multiply your final horizontal position and depth? So get position application result, and that's going to take a string with this type. I have a typo, let's fix that. And what I can do is that it field type. This is going to be a type and constructor. You can say dive to dive. Cool. We can create this class now. Public. Move to awesome, so that's all good. Let's create this create method dive. That's fine. List of string data, we can send that to list, just so that it's clear that it's something that's immutable. and we're going to return 0. Also going to have my tests running here. So right now if I run this, it's going to fail because the expected result is 150 from the problem statement, and I'm just returning 0. And while we wait for it to build, we can start writing the code. So let's bring up the problem statement. Now we can see that it basically says that forward x increases the horizontal position, down x increases the depth, up x decreases the depth. And those are the three inputs I've got. With forward, where it's giving us what direction we're moving in and the amount we're moving in. So we can start with print horizontal movement is equal to 0, and then vertical movement is equal to 0. What we want to do is return horizontal movement into vertical movement. Another question becomes, how do we get these? So the first thing we can do is start going through the data, and for each where it's a movement data. Now the movement is a string of, if you look at the test data, it's forward 5, so it has a string component and then it has an integer component. So we can split it. So we can start by splitting it into movement.split. We can just split it by space. We can say remove empty entries. Right, and so we can just name it to split for the time being. So now we've got a split. Now we've got the direction, which is split of 0, and movement amount is equal to split of 1. Then we do console. Let's not do that. Now what we can do is we can do if direction is equal to forward, we can say horizontal movement plus is equal to movement amount. That's complaining because try parse. We'll just what do I think try parse probably needs amount, right? So we get that. And then we can do else if direction is equal to, so we can go back to the problem statement. We can see the other two directions are down and up, and up. Down increases the depth and up decreases the depth. So it's down, it increases the depth. In this case it's vertical movement, and if it's up, then it decreases the vertical movement, and we just return. So now it's not copied, so the reason it's complaining is because it's not copied over the solution or the test data.json. now let's try running our D2 tests and see what happens. Close those. You can see that this one's passed, so code is working as expected, and this returned 194.293. I'm going to do is I'm going to just plug that back in here and go to the advent of code and submit my answer. So you can see that's the right answer. I've got the it's release the problem statement for part 2. This will move this to the top right. So part 2, it says the plant course doesn't seem to make any sense. So now we need to track a third value, which is aim, and the changing. So before we actually go there, let's just commit what I've got so far. Bear with me while I just bring that up. While it's commenting it on the side, let's go through the problem statements now. So now they're changing what down does and up does. So we need to modify a problem statement to that. So okay, I'm just going to commit this code as well, so you can see what I'm doing. I'm just going to get that and copy that. I'm going to commit this. Oops. Add into part 1. So now that's committed. Now we can go with the part 2 changes. So first thing that we can notice they've given is the example which remains the same, but the result is different. So let's change that. We'll change that to 900, and we still don't know the result of the actual input that they've given. We should copy that. We should make it for D2 test data, but in this case we'll now say part 2 position. Let's call that actually that's fine. I'm going to position a multiplication results. Create method dive, which is fine. That to a terminal list. What I'm going to do is to start over with is just copy all of this, right? Because we're going to be making a few changes to this code, but not too much, and we can use this as a base. Now they're already saying we need to track a third value, aim. So let's start at 0, so we can create a variable aim. Now down x increases your aim by x units, so now we can say down x increases aim, and up x decreases your aim, so we can do that. And forward increases your horizontal position, we're already doing that, and it increases your depth by aim multiplied by x. So it's going to be vertical movement plus equal to, you can say, e into movement amount and so if we now run the tests again, let's see what happens. So we can see this one's with the 900, it's already passed, so that means this should be given us the correct results. In this case it is this really large number, and we're going to go back and plug this in, submit. So you can see we've completed day 2. Now at this point we've completed the challenge, so it's kind of done. But if this was code that I was trying to keep for a long time, I would probably change a few things. Obviously this movement amount variable doesn't make sense anymore, so I would change it to something which makes a little bit more sense, and instead of movement amount I might just make it amount. Or let's see if we can find something from the calendar. So I think I can still see the problem statement. So part 2, and then I need to track over. So we can just change that to units. Right, and that becomes a lot closer to this. So I hope you like this video, and I will be hopefully doing day 3 tomorrow.